All right, next example. 3x squared plus 8x equals negative 2. Now, there's a trick here that quite a lot of people fall for. Remember I said the first step is to get everything onto one side of the equation and get it in this form so that it equals 0. Some people will fall for a silly trap of saying, hey, I can just factorize this side, bring an x out the front, and now I've got this. Now the problem is you can't use the null factor theorem if you do that. You can't say something times something is negative 2, so one of them must have been... No, there's an infinite number of numbers that can be multiplied together to make negative 2. So we really can't afford to make that mistake anymore. If that's something you know you do sometimes, write yourself a little note and highlight it. Get everything on the one side. So first step, 3x squared plus 8x plus 2 is equal to 0. Now we can work with it. Now, no matter which way you factorize, you should be able to work out quite quickly and easily that this one is not factorizable. If you're using the 2 pairs method, then you'll say I need factors of 6 that add up to 8. And quickly jotting down the factors of 6, you can see that neither pair adds to 8. Somebody who's using the cross method similarly should be able to see that they'll have 3x and x, and no matter whether they put the 1 here and the 2 here, or the 2 there and the 1 there, they can't make 8x with it. So a quick inspection tells you there's no point barking up that tree. It's not factorizable. So now just launch into using the quadratic formula. X equals negative b. Now b is 8, so we've got negative 8 plus or minus the square root of, now I know 8 squared is 64. I don't need a calculator there, so that saves me some time, minus 4 times 3 times 2. And again, you could do that part in your head if you like, and say, well, I've got 24 there, so let's just write down 24. That way we're cutting to the chase. On the next line, I can simplify it even more. 2 lots of 8 is 6. Now I can see here I've got the square root of 40, okay? So perhaps even, it might look a bit messy. It saves me a line of working, having to write the whole thing out again, just to simplify it like that. Now at this point, if I want my answer to be exact, and I don't want to round it off, I can use the fact that the square root of 40 is equal to the square root of 4 times the square root of 10. And I know the square root of 4 is 2, so I've got 2 root 10. So at this point we can say x is equal to negative 8 plus or minus, and instead of writing square root of 40, let's write 2 root 10 over 6. Now, can this be simplified even more? It can. 8, 2 and 6 are all even numbers. So we can halve everything on the top and halve everything on the bottom. Make sure you do all 3 terms though. Never cancel just these 2 or just those 2. Terrible mistake. So halving minus 8, halving 2 root 10, we just get 1 root 10, and halving the 6, we get 3. And that's actually going to give me a nice, perfect answer, quicker than reaching for the calculator, and it's exact. I don't have to round it off. Last example now, and I want to use this one to illustrate an important point. There won't always be solutions to your quadratic equation. And it's good to know that, so that if you don't find any solutions, you're not going to worry about it. So in this one here, I can easily see I can't factorize it because there's no factors of 5 that add up to 3. So if I was to use the quadratic formula, then I would say negative b, that's negative 3, plus or minus the square root of b squared, that's 9, minus 4 times 1 times 5. Well, that's minus 20 all over 2a. Now, here's the problem. 9 minus 20 is negative 11, and we can't take the square root of a negative number, okay? So as soon as I see that, I can see that there's no solutions. Now, what do? We simply state what we've found. We write therefore, with 3 dots, no solutions. And we're finished, okay? Now that's a perfectly adequate answer to this mathematical problem. Now when you're using the quadratic formula, it's quite common to find what's called the discriminant first. And the discriminant is this part here, the b squared minus 4ac. And the reason it's common to find it first is because if you see that it's a negative number, in other words, if the discriminant is less than 0, there will be no solutions. And if the discriminant is equal to 0, well, if it's equal to 0, the square root of 0 is 0, isn't it? And so if we're adding 0 and subtracting 0, we're going to get the exact same answer. So there won't be 2 solutions, there'll just be 1 solution. Whereas if the discriminant is greater than 0, like it was in the last example, then we're going to get an actual number here. And when we have this number plus it or minus it, we're going to get 2 answers. So that gives us 2 solutions. So just be prepared for all 3 of those situations to occur. And when we get to graphing quadratic functions, this will make a lot more sense when we're looking for x-intercepts and we find that there might not be any, there might be 1 or there might be 2.